Okay, so today we're going to go over U-substitution, but I want to look at it in a different way. So when we learned chain rule, and that's where we want to start, I want you guys to watch as I'm taking this derivative, but I'm going to use the explicit chain rule style. Okay, what we first learned when we learned how to take chain rule. Okay, so I've got a function inside of a function. When we first learned this, we said, okay, I'm going to split this up by first finding and deciding what's my u. And in this case, u is the inside function 2x cubed plus 1. Okay? And then we rewrote this as y equals u to the fourth. Okay? So this is how we originally learned how to do chain rule. And then we took the derivative of this one with respect to u, and that gave us 4u cubed. And then we took the derivative of this one here with respect to x, and we got 6x squared. Okay? Then what we did was we took dy over du and multiplied it by du over dx, and that would give us our dy over dx. So we took 4u cubed and multiplied it by 6x squared. And then we simplified, but we also plugged back in our u. So we got 24x squared, and then you plug u back in, which was this, 2x cubed plus 1 cubed. And that's how we originally learned how to find the derivative doing chain rule. Okay? Now, notice some of this looks familiar. Okay? So for instance, how we picked our u in chain rule is very similar to how we pick our u in integration by substitution. Okay? But then we learned like the inside-outside rule. So we learned how to do it, the chain rule, doing it this way, where we took the derivative of the inside, and that gave us our 6x squared times the derivative of the outside, which should be 2x plus 1, subtract 1 from the power. And we kind of forgot all about all this other stuff that we did. Okay? And that's part of the reason why U-substitution becomes more difficult, is because we forgot where chain rule came from. And U-substitution, or integration by substitution, is basically the anti-chain rule. So that's what we're going to do. I'm going to find the integral of this, okay? Which is the derivative we just found. Okay, so when I finish, I should end up back there. Okay? So, when we do integration by substitution, we say, okay, we do the same basic first step. We say, okay, u is the inside function. So in this case, it's 2x cubed plus 1. Okay? We actually take the derivative of this just like we did originally in chain rule. You take the derivative of both sides with respect to x. You get du over dx equals 6x squared. And then we solve for du. We get the differential du by itself by multiplying both sides by dx. Now we often skip this step right here. This step right here we often skip when we do integration by substitution. And we end up right here. Okay? We go straight from here to here. Because we know that we just don't have to do that to do it. Okay? Now, that means that this right here, that's u. Okay? And everybody will agree with me that 24 right here, that is 4 times 6. Okay? So I can rewrite this as the integral. I'm going to put 4 out here. And then I'm going to end up with 6x squared times 2x cubed plus 1 cubed dx. So when we do our substitution now, this right here is u, and this right here, this part is du. Okay? So when I rewrite my equation, it's going to be 4, and this is going to be the integral of u cubed du. That's my substitution part. So then I take the antiderivative. So you add 1 to the power. So you get u to the 4th over 4 plus c. We have this multiplication by 4 here at the beginning that we can't forget. And then 4 divided by 4 is 1. So we end up with u to the 4th plus c. And then we take this and plug it back into here. So we get 2x cubed plus 1 to the 4th power plus c. And that's our antiderivative. Did we end up back where we started here at the beginning? Yes, we did. And now you can kind of see, let me zoom this out real quick. Now you can kind of see how these two link. Notice in both, our original right here and right here, it's the same. And notice on our other side here, look, this right here. So basically, the chain rule derivative that we were doing and the integration by substitution antiderivative are literally inverses. They are exactly the same operation in exactly the opposite order. The only difference is that we still end up with this part right here. Our u is the same in both of these. Or even our du is the same in both of these. They have to be. Because that 6x squared that we ended up with when we took the derivative has to be there. If that 6x squared wasn't there, we'd have to do it in a different form or different way. Okay? So I hope this helps to kind of show you U-substitution by actually showing you where it came from in the original chain rule derivatives.